All right. I'm going to combine the two that we were going to go over Friday. So open up to star formation and nuclear fusion. Okay, what do we know stars begin with? It's sun formation now. What do we know? Go. Notebook's open. Then close the Chromebook. Stars are formed from what?
Gas. Helium.
Yeah, hydrogen gas, dust. Now, there's theories out there that stars have gone through their life cycle, went into the old nebular explosion, threw the material back out, and then came back together. So yeah, stars form from, much of it is hydrogen gas, and then what's loosely defined as dust. Then what happens? Okay, gravity starts pulling more and more of this material together. And as gravity starts pulling more and more of this material together, it starts to tighten up. What starts to increase? Granted, you got gravitational pull working, but what else is increasing in the interior of that protostar? Pressure. So gravity and pressure are really the two big forces that start pulling enough material together. As you increase the pressure, and pressure is nothing more than how often these particles are bouncing next to each other. As you increase the pressure, what else starts to go up? Well, we know gravity's pulling it in, and therefore gravity's pulling this material together. The pressure's increasing, and then what else is going to start to increase? The what? Temperature. Temperature will start to increase. So we got this protostar there, and material starting to collect. Gravity's doing its thing. The pressure is increasing. The temperature is increasing until eventually, what can happen? No, it's not going to explode. Oops. Nope. Oh, maybe I should use yellow. That'd probably be a better one. I'll use yellow. Nope. We can get the star. When a star ignites, that's when nuclear fusion takes place. And what is nuclear fusion? Where two what combine? Where two hydrogens combine to give you a helium. And what else? Grace, what else is formed? Just what I'm talking about. Energy. Energy is made out of matter. When two hydrogens combine, what ends up happening is it forms that helium. There's a little matter left over, which is converted to pure energy. This is Einstein's E equals mc squared. And this leftover matter that is converted to energy is what makes us all the energy that we see in a star. Light, heat, all the whole electromagnetic spectrum that we talked about earlier. This really happens in the interior of the star. How does this energy get to the surface then?
The magnetic field pushes the energy out.
What processes, or what process? Yeah, convection currents. Because we know energy, especially heat energy, can travel through a liquid or a gas through convection currents. Notice the sun is not a solid. Now, in the core, as the sun starts going through its lifespan, and what is the lifespan of the sun? About 10 billion, and approximately now it's at what? At about 5. So it's about halfway through. So as the sun keeps burning, it keeps doing this. That nuclear fusion takes place. So the sun keeps burning, keeps it's that medium yellow star. And then what's the next phase of the sun's lifespan? Okay, it's going to get into the red giant phase. In between, when you guys are done, let me know. This is all in the assessment next Monday. As this sun starts burning, as it starts using up the hydrogen's not going to last forever. It's fuel. It's going to eventually run out. As it starts to push into this stage, what starts happening with the red giant? What's getting formed there? What elements are getting formed?
Is it more helium getting formed?
Well, you're going to get helium and everything up to what? All right. The sun is going to take it to oxygen. What ends up happening is helium start to fuse to create something else. A helium and another element will fuse to create something else. The sun, our sun, really will get to the element of oxygen. Bigger stars are going to get to the element of iron. So depending, the sun can get to oxygen. Larger stars are going to get to iron. So you've got the meat. You guys are done. Let me know. It's rude. So you've got the elements greater than helium being formed from nuclear fusion in between as it's burning and getting to the red giant. If it's a sun-like star, there's enough pressure. Turn that thing off. There's enough pressure. There's enough gravitational pull that it's going to get to the element oxygen. Bigger stars are going to get to the element of iron. So this is where the elements up to iron are being formed. Turn that. Questions? Yeah? I'm not there yet. I'll get there. All right. Nothing on that one. All right. Now, from here, it really depends, and you can also look on this over here, what's going to happen. The sun's going to swell up, and the sun will swell up about to where Mars is going to be. It's going to swallow up all those. And then if it is our sun, go. Now let's do this. If it is our sun, we're going to get to a planetary nebula. So sun-like stars are going to get to the planetary nebula stage. During the planetary nebula, really it just starts shedding off everything, the pressures, the temperatures, the gravitational pull gets so great that in planetary nebulas, this is where you get the other elements greater than iron being formed. So when you look at a planetary nebula, you get the other elements greater than iron or heavier than iron. Get everything above. We're not going to get into atomic numbers. Suffice it to say, you're going to get into the heavier elements than iron being formed. Yeah.
Would the gravity of our planet kind of move with the sun as it grows, or would
we're just going to get fried to a crisp. That's all there is to it. We're going to get fried to a crisp. That's all there is to it. So once the sun sheds off its outer part in the planetary nebula, there's a core still sitting there, very, very, very hot, but very, 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 very small. Again, we're speaking relative speaking here. And that's called a white dwarf. Eventually, the white dwarf is going to burn out into a what? Come on, guys, you all did this one. Oops. Nothing new there. So the white dwarf is eventually going to run out of fuel. It's going to start fusing everything until there's nothing left. And then the sun is going to end up being a brown dwarf. All I'm doing is going right over what's in your notes already. Then at that stage, it's just an empty rock sitting out in the galaxy somewhere. This nebula, though, is now the birthplace for other stars. That nebula can now recondense. You can get pressure and gravity going, and you can get stars being formed again. If we get to the point, let's see. We have massive stars, like blue giants. So if we have more massive stars than the sun, such as blue giants, and as you guys went through your Google Sky activity, you found that these are very, 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 very large stars. And you can see they're out in this stage here. They'll go through and do the same thing, except they're much, 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 much more massive. But when they burn off their fuel, they won't form a planetary nebula because there's so much material there. They're going to form a supernova. So they'll blow off and form a supernova. Kind of a planetary nebula, but on a much, 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 much larger scale. And in fact, there is so much matter there, and it is so dense and so compact that after a supernova, what's formed? The infamous black hole. the infamous black hole. So from this one, you're going to get the infamous black hole. That I think we're long gone before we even get to that point. The sun is not big enough for a black hole. For a black hole to form, you need a star that has about 3 solar masses.
Our sun has one. Our sun has one solar mass.
A solar mass would be the mass of our sun.
Oh.
So you got to have 3 solar masses.
And we base everything off of our sun. Get that all size of that.
Yep. The key thing on that whole idea of nuclear fusion, though, is that some matter is converted to pure energy. And that energy in the interior of the sun can get to the outside, the surface of the sun, through convection currents. Anything to add on those? Kind of wrap those 2 lectures together that we're due for Friday. Yeah? Yep. Then iron, yep. Yep, supernova phase will get you there too. Any questions to add to those? All right. Go ahead and get out your spreadsheets.